Hey everybody, welcome back to my electronics workshop. So I'm having a nerdy moment, trying to finally tackle a project that I've had on my work list for a little too long, and I've run into some hurdles and problems that kind of pushed out the timeline on getting this done, but I'm starting to make some headway on it, so I figured a video was in order. What we're looking at are some Motorola Radius radios. These are specifically low band VHF of the radio frequency spectrum, most prominently used in commercial business. I think originally they were about like 36 megahertz to 42 megahertz range. They had these in a couple of different flavors. A lower frequency version that was closer to 29-ish megahertz, and then they had the I think one or two different versions of the low band VHF for that 30, I think it was like 36 to 40 some. Anyway, there's Motorola. Let's just say that Motorola has Motorola things, and they do Motorola stuff. So these are specifically the higher frequency version of low band VHF, and because of that you can achieve nudging them outside of their normal operating range. And in our case, we want to operate them from anywhere from 50 megahertz to 54 megahertz. That's the frequency space amateur radio operators have available. This one will be running in the transmitting on the 53.45 megahertz range, and then of course we have our receiver frequency as well. It's a full duplex repeater. So a part of the conversion process to do these radios, you have to go through and you have to realign the sensitivity of your new frequency spectrum you're aiming for. So that can be done through a couple of different methods, but I find that the SINAD or SINAD yields you the best, most accurate range of knowing that the sensitivity from this frequency range to this frequency range is even or preferred. So that modification requires you to use some brass screws in the tuning coils for the receiving section. There's a nice little write-up on repeaterbuilders.com on how to accomplish that with these radios, and that was a good educational starting point for working through that modification. You also have to realign the VCO to adjust the voltage range to operate in or a little bit beyond the 50 to 54 megahertz section. You can, in some cases, you can maintain the business frequencies as well as have the amateur radio stuff. I put more focus on making sure that the amateur radio side of this will be the most sensitive and operate as smooth as possible. So that's kind of the process you have to go through. It's a receive VCO and a transmit VCO, and those do need to be adjusted to work outside of their frequency range. The power amplifier on these, so these are like, I believe, a 60 watt capable amplifier on the back end, that black finned part, which you can actually see on this one. That black finned part is all power amplifier. And so Motorola's got some interesting things that you have to do. These do have what they call an automatic power control function, which isn't based on the temperature of the finals or the power amplifier. It's based on time. So that threw me an interesting curveball that was not going to work for the repeater operation that I'm hoping for. So that's one of the biggest things that I had to work through. And there is a modification for a lot of the Motorola Radius series of radios. That's a series, not necessarily a model number. So that's a whole Motorola thing, and it's on its own that can be a little interesting to work through in some cases. So there is an amplifier modification that has to be done to make it work and provide good RF output on the new frequency range, and that usually entails either closing off or spreading out some coils. But you have to be careful about doing that because, like some of the CB radio stuff that I've messed with, when you start opening up the coils and playing with things, you may not necessarily be getting any more power on the frequency you're intending to transmit on. You'll be getting the harmonic output power, or the harmonic power will actually be higher. So that can give you a false reading of your fundamental frequency may actually be less power, but your harmonics may be actually more power. And because most meters don't have the ability to isolate and say, I'm transmitting on this frequency, how much power is on this frequency versus the entire, like, how much power is this thing just putting out in general. So you really do need to pay attention to your harmonic output power. And a part of those coils in the back end are for stopping or limiting how much harmonic interference the radio will generate. And you do need to stay within a certain range or a certain amount of power, because in our case, our second harmonic on our frequency of 54.450 is in the FM broadcast range, about 106, 106 megahertz-ish in that section. And I was hearing the radio quite easily on that frequency, so that there's some work to do on the harmonics on these still. And then the third harmonic, so you have your fundamentals, the frequency that you're actually intending to transmit on. Your second harmonic is the second frequency that the radio is transmitting, and your third harmonic is the third division of that. So our third harmonic was sitting around 160 something megahertz, which is right within the railway and train frequencies. So that's, again, another big problem. So these are the reasons why you have to pay attention to the harmonics that RF equipment can generate. And if you don't properly adjust them or put in band limiting filtering, choking to kind of take those frequencies and prevent them from exiting on an antenna. So those are the things that you have to keep in mind. Anyway, I'm not going to beat that horse anymore. There are ways of doing that, and Radio Reference, again, does touch on some of that in their previous articles for these particular or even similar radios. Okay. Really, you can do all that testing with a good spectrum analyzer and a way of sampling the RF output. So say you have a dummy load, you might have a little box that you'll put between the radio and your dummy load, and it'll offer a certain amount of attenuation so that you can feed it into a piece of test equipment to see what are my byproducts that I'm having come out of my radio. So good to know. That's why Baofeng radios got such a bad rap, because their harmonic management is not always the best. So okay, so that's what we've been working through on these. That's what I've been hammering out all the problems. But the automatic power control, the APC functionality of this particular type of radio, this particular brand and this particular model, like I had mentioned earlier, does not manage the output power limiting based on a temperature. It actually does it through a time base. So a built-in functionality, there's an analog to digital converter IC, and there's some logic that, depending on how long the radio is keyed down, it's like doing a duty cycle clock to see how much, what's the duty cycle calculated to be. And what'll happen is, if you exceed the duty cycle that is put in by Motorola, it will start progressively stepping the RF power down, and down until the point where the radio is almost putting out no RF power. So it's taking that PA and it's just essentially shutting it off at a certain point. So it's meant to thermally manage these, because if they are in a mobile application, in a hot truck, or whatever, you really don't want to run them to the point where they're just melting down, melting the solder. In a sense, it happens quite often on some radios where the actual RF output transistor will desolder itself off the board and cause some intermittency. So these don't have thermally managed duty cycle based calculations. These are all time based, from what I gather. I might be wrong. Maybe you can tell me in the comments, but there is a bypass that you can do. It's a modification that takes essentially that power limiting capability out of the radio, bypasses it, basically cuts a trace on the board, and then you put in a manual power control functionality, which is like a multi-turn potentiometer, some resistors, and you make the connections between the transistors that are responsible for managing that. What you lose doing that is the ability of, when you program the radio through in the service portion of the radio software, you lose your ability to adjust your RF power output. So that's kind of the downfall, but in my honest opinion, if you appropriately set your RF output power on these for the purpose that you're using them for, you're not trying to get more power than they were really intended to do, and you keep in mind your duty cycle. If these are a 60 watt one, I might back it down to 35, 40 watts max, just keep it under, and that'll make thermally managing the temperatures a lot easier, especially if you're doing some forced air cooling on them. It really does help. So all things that you need to know about a lot of the radios that are being repurposed from being non-full duty cycle rated to amateur radio use, where you're kind of pushing those limits a little bit. And fight the urge. Just because it'll do 60 watts or more doesn't mean you should, because you're not going to really gain much other than just a bunch of heat and a radio that's eventually going to fail sooner than later. So but that brings me to my next subject. Is I just don't want these radios all loosey-goosey and being maybe put on like a rack shelf or kind of just hanging out. I wanted them to be a little bit more professionally type of an installation for our repeater site. So on my DMR repeater that I have up in operation at our repeater site in Rib Mountain. And by the way, if you're interested in what repeaters we operate in our club, that would be the Rib Mountain Repeater Association. And if you want to check us out on the internet, on the web, hey, maybe if you want to throw us a little something for keeping our equipment in good operating condition, and maybe help us kind of build off and do our stuff, check us out. It's the rmra.club. So rmra.club. We would greatly appreciate it. And if you are an amateur radio enthusiast, go ahead and join the club. And it's all easy to do online. You don't have to do a paper or mail-in or anything like that. You can all do it directly from our website. So I'm gonna stop selling that and just focus on this. And it's not technically selling, so I hope not. Anyway, so the next piece of equipment I have here, so I wanted to put it in housing. And I did this for the DMR system that uses some Motorola the PM400 series equipment. And I had fully intended on using Motorola Radiuses originally, but changed my mind. But these are Gem Sound 2 rack unit Pro Audio, they call them. The amps were really just kind of useless junk. But the housings are very useful for me. So I had a pile of those from years ago, and just place I worked for, they would blow them up, burn them up on the bars and stuff. So the amplifiers were literally junk. And then eventually they just said, no, we're not going to use those anymore. After some nice suggestions of saying we should really stop buying these really cheap garbage amplifiers and get some true high quality pro audio stuff. Because Gem Sound and Pyramid and a bunch of those other brands, they tended to market amplifiers that were rated to say they were like 2,000 watts. Well, in a sense, they could barely maybe keep up with 200. So it's that if struck by lightning power rating. So anyway, that offered me the opportunity to basically gut out everything on these housings anyway and use them for enclosures. And that is what I will be doing with these. I have the faceplate off of it that has the rack ears, and that's going to be going in the garage workshop for me to cut it all out with a basically a death wheel and try not to lose an eyeball. So that'll get modified, and then I usually give them a little bit of a nice paint, little coating of paint, and prep them a bit to make them look a little bit nicer and add a flare, a little color flare. Maybe I'll paint this one purple just to be that guy. Call it Barney. But the housing can be easily modified. They already had a nice giant hole in the front that was essentially just for a generic housing type anyway, so made this a little bit easier. But I do have to work out some mounting options. How do I mount these radios in here? How do I keep them secure? How do I keep them cool? And that brings me on to my next point of discussion. I like to use these AC Infinity 80 millimeter or bigger fans. They're a AC powered 110, 120 volt. Nice metal, good bearing construction. They're not super cheap, but they're also not the most expensive. They're good quality fans. I've been happy with them. So I'll probably end up running a pair of those on the back, directly blowing on the heatsink of this particular radio or this particular position, because that'll be the transmitting radio. I'll probably put a baffle divider in there with a little bit of venting on this section to kind of allow some air to pass across the receiver. It's not going to get nearly as hot, but it'll be just good to have some airflow heading that direction. Plus, I need to have a bulkhead for the cabling and stuff to go anyway for the power and any of the control wiring that I'll have to have for an external controller. So that'll handle that. And in the other repeater that I built, I did a very similar thing using a pair of these, blowing across the transmitting radio's heatsink, and it seems to be, knock on wood, doing a good job. So this will be externally powered. My DMR repeater, I did put a Meanwell power supply inside of it that I think was good up to somewhere around 25 amps. So it's a little bit overboard, and that may offer me the possibility of using that Meanwell power supply to then also power this repeater if there's enough constant duty cycle capability built into it. So I like to overbuild instead of kind of skate that edge of is it enough or not. So that hopefully means better longevity to the equipment. So that's kind of the idea, that this will be powered externally. The fans will have to be powered by AC. I may change my mind and use some like Noctua 12 volt computer style fans and then just power it from the repeater itself, but I don't know if it really matters. I think I might just go for these since I know I like them. They work well and they've held up very well too. Noctua makes fantastic fans, but these are heavy cast aluminum. They're built well for the rugged purposes I'm hoping that they'll hold up to in this. So it's going to spend most of its life just rack mounted anyway, but it's good to have that built in. So that's the plan. I'll just have to work out some mounting. I might 3D print some bracketry and things. I'll end up most likely printing them out of PETG, some type of a higher, slightly higher melting temperature in case things get a little warm in here, to offer the support for the radios as well as keep them secure. So that's the plan. I hope it works. We'll see how it plays out. But anyway, if you enjoy my videos, hit that like button if you want to. Hit the subscribe as well while you're heading out and at the end of this video. And if you want to be notified of the nerdy things that I have going on in this workshop, go ahead and hit that bell so it'll notify you when I have something new out. But once again, thank you for joining me in a nerdy moment, and hey, stay nerdy.